What's up, Logic fans? Welcome to another video. Today we hit section 5.5 of the text, our fifth section on quantificational semantics, and here we explore all of our central semantic concepts. Let's rock. So today all of our hard work on presenting interpretations and using Tableau techniques from the previous four sections basically all comes to a head and pays off for us, because now we can put interpretations to work for defining all of the important central semantic concepts that we want to define for quantificational semantics. Now, when you first take a peek at section 5.5, it can look a little overwhelming and intimidating, and that's because of the sheer amount of concepts that are covered. And there's 6 big ones, and there's sort of the negations of each of them as well. However, it's not as tough as it looks, because now that we've actually done the legwork on understanding interpretations and Tableau, we can define each of these in terms of them, and they come together really quickly, and a lot of these are related in such a way that I think you're going to be able to pick it up all very, very quickly. So if you hearken back to chapter 2, okay, when we were doing semantics for propositions, we defined the notion of a tautology. There's going to be the exact same notion defined here for quantificational logic rather than propositions, except it's going to be defined rather than in terms of truth tables. It will be defined in terms of interpretations. Same thing for contradiction, same thing for logical contingents and equivalence, consistency and inconsistency, and validity and invalidity. So all of this parallels exactly earlier work you've done in chapter 2 with propositions. So as long as you're keeping all of that in mind and realize they're supposed to be the same concepts, but for quantificational logic, a lot of this is going to be a lot easier as you're already familiar with all of the main concepts. So let's start by looking at the notion of a logical truth or a tautology. So if you recall from chapter 2, the notion of a tautology, right, was a proposition that can't help but be true, right? It must be true. It's true on every row of its truth table, right? Okay, well, the parallel notion here is that a quantificational sentence, so not a proposition from chapter 2, but one of the sentences from chapter 4, okay, something with quantifier apparatus involved in it, all right, it's semantically logically true, okay, i.e. a tautology, okay, it's a logical truth. It must be true if and only if it is true on every possible interpretation. Okay, now I want you to think really hard about this definition for a second, right? In particular, I want you to think about how strong the definition is on every possible interpretation. There cannot be a single interpretation on which it's false. Similarly, there can't be a single row of its truth table according to which it's false in the case of a proposition, right? But this is a massive and a super, super duper strong requirement, okay? I mean, if you think about it, right, there's infinitely many possible interpretations out there, right? There's all the interpretations that have just one object. There's all the interpretations that have just 2 objects. There's all the interpretations that have just 3 objects, and so on into infinity, okay? And it has to be true on every single one of them. That's the requirement here. So let's look at an example for a second. So here's 2 sentences, okay? Only one of them is semantically logically true. That is to say, only one of these 2 is a tautology. Intuitively, which one do you think it is and why? Pause now. Okay, hopefully you've had a chance to think about this, but the correct answer is this one. This one is the tautology. Now, as to why, it might stick out to you that this looks a little bit like the law of the excluded middle, right? P or not P. So this has a little bit of this in it, okay? And that's the sort of tip-off. Now, this is not of the form P or not P. This is a universally quantified sentence, but inside of here you do have a P or not P, and that was supposed to be your kind of hint, okay? Another way you could have thought about it was that since I told you that only one of them is a tautology, you could think about trying to prove which one of them is not, okay? Now, let's say you're trying to prove, for example, that this sentence is not a tautology, Okay, how could you prove that it's not a tautology? Well, in order to be a tautology, it has to be true on every possible interpretation, right? So, provided you can give me an interpretation, any interpretation, just one, according to which the sentence is false, you will have thereby demonstrated that the sentence is not, is not a tautology, is not semantically logically true. So, pause now and see if you can provide me with an interpretation. Let's do it in, say, 2 objects, according to which this sentence is false, thereby demonstrating that this sentence 2 here is not semantically logically true, is not a tautology. Pause now. Okay, so pretty straightforward, right? So this says everything has to have satisfy this description. So if we have 2 objects, A and B, then they both have to be this way. But all we really required is one of them not to be that way, since it's the universal everything. So A isn't this way. Therefore, here's an interpretation in 2 objects according to which this sentence is false. And since by definition, a logical truth, a semantic logical truth, or a tautology has to be true on every possible interpretation, this sentence is therefore not a tautology, okay? And that's how you prove that a sentence is not a tautology, okay? Now, how could you prove that a sentence is a tautology? Well, in this particular case, right, I told you that one of the 2 was a semantic logical truth. Okay, and so then you could thereby figure out which one was semantically logically true by sort of figuring out that this one was not a semantic logical truth, and then by, deduction, just figuring it out that way. But suppose I hadn't given you this one, right? Suppose I had sort of said, here's a semantic logical truth, which it is, prove it, okay? How could you prove that something was semantically logically true? How could you prove that a sentence like this one is in fact semantically logically true? Well, it turns out that by only using semantic techniques, presented in chapter 5, you can't. You cannot prove using semantic techniques alone that a given quantificational sentence like this one is semantically logically true. You cannot prove that it is a tautology. Now, in chapter 6, you will be able to prove that it is a theorem of logic. Okay, and then in more advanced courses, you can explore ideas about how the syntax of chapter 6 is related to the semantics of chapter 5, and then you can start establishing some things. But that's beyond the scope of our course and our text. Okay, those are called soundness and completeness proofs, and I highly encourage you to discuss them with your instructor. But the basic idea is, for our purposes, you're looking at a sentence. You can kind of tell intuitively that it perhaps is a semantic logical truth, that it will be true on every possible interpretation, but we don't have the means by which to demonstrate that, okay? And the reason why we don't have the means to demonstrate that is because it has to be true on every possible interpretation. That would mean it's got to be true on every possible interpretation with one object. It's got to be true on every possible interpretation with 2 objects. It's got to be true on every possible interpretation with 3 objects, and so on. And you just can't scroll through every logically possible interpretation to verify that. Okay? So, we do explore some of the limits of quantificational semantics in the last section of this chapter. I believe it's 5.9. So do take a look at that if you're curious about some of the limitations about what can be done. But what we can do is prove that a sentence is not semantically logically true by providing at least one interpretation according to which the sentence is false. Okay? So that's what we can do, that's what we can't do, and why, and I hope it makes some sense. But notice the payoff of all of our work by providing interpretations using Tableaux technique. It's very straightforward to prove that a sentence is not a tautology simply by presenting one interpretation according to which that sentence is false. And the payoffs are just beginning, because we can do the exact same thing with not just the notion of a semantic logical truth or tautology, but also with the notion of a semantic logical falsehood or a contradiction. So let's look at that. Okay, so new concept, the notion of a semantically logically false idea or a contradiction. So harken back to chapter 2 where we learned about contradictions in the context of propositions, right? And we said that a proposition was a contradiction just in case it was always false. On every row of its truth table was false. It couldn't possibly be true, right? Same idea here, all right? So a quantificational sentence is semantically logically false if and only if it is false on every possible interpretation, okay? If and only if it is false on every single one of them. So it follows the exact same structure as the logical truth that we just looked at. All right, take a look at this example. Exactly one of these two sentences is semantically logically false. That is, say it's a contradiction. Can you figure out which one? Pause now. Okay, hopefully you had a chance to figure it out, but it turns out that this sentence is semantically logically false, right? This is a contradiction, and your clue there is that it does have that sort of P and not P built into it, okay? It's not of the form P and not P because of the existential quantifier here, but inside of here you've got a little P and not P going on, and that's supposed to be a sort of clue for you that that would be the contradiction. However, just like with the case of tautologies, you're not going to be able to prove that this is a contradiction. However, you could look at this sentence and say, hey, that's not semantically logically false. This is not a contradiction. How do I know that's not a contradiction? Because I can provide an interpretation according to which the sentence is true. Right? So if it were a contradiction, if it were semantically logically false, then by definition it would have to be false on every possible interpretation. Yet here's an interpretation according to which it's true. Therefore, this sentence is not a contradiction. Okay? And once again, you can prove that a sentence is is not a contradiction by providing at least one interpretation according to which it's true, but you cannot prove that a sentence like this one, okay, is a contradiction simply because you can't scroll through every possible interpretation and check whether the sentence is false on every single one of them. Again, we will be able to prove that this, the negation of this rather, is a theorem of logic starting in chapter 6. So we do have other methods available to us, but from a semantic point of view, okay, we cannot show that this is in fact from an exclusive or purely semantic point of view, we cannot show that this is a contradiction, even though it is. But we can prove that sentences are not contradictions by providing an interpretation according to which the sentence is true. Just one interpretation will do. And okay, let's spill into the next video, B5.5b, and keep exploring some of these semantic notions, and you're undoubtedly noticing that, yeah, we can define this stuff pretty quickly just in terms of this Tableau interpretation stuff that we've spent a lot of time doing. Catch you on 5.5b.